Okay, so I have started the recording. So first we'll see what is a cold room. So a cold room is used to store perishable goods such as meat and vegetables to slow down their deterioration and preserve them as fresh as possible for as long as possible. Okay, so our objective is to keep that vegetable, fruit or meat as fresh as possible and for a longer duration. So what you see on this right side, this is a cold room. So there are many companies. Blue Star also provides the cold rooms. Then there is one company which is famous for this cold rooms and this ice cream fridges. That is a Self Frost. Okay, so there are various companies you can find which are manufacturers of this cold room. Okay. Second is heat accelerates their deterioration. So the products are cooled down by removing the heat. So heat is the criteria which accelerates their deterioration process. Deterioration means the process of respiration. So we have studied this process of respiration in our 8th standard or 9th standard. ठीक आहे. रेस्पिरेशन इज अ प्रोसेस. त्यामध्ये काय होत असतं की आपण ऑक्सिजन घेतो. ठीक आहे. आपण ऑक्सिजन घेतो. देन विथ द हेल्प ऑफ ऑक्सिजन दॅट ऑक्सिजन ऑक्सिडेशन प्रोसेस इन आवर बॉडी ऑकर्स. आपल्या जे काही ऑर्गॅनिक सबस्टन्स आहे त्याचं काय होतं ऑक्सिडेशन होतं. त्या प्रोसेसमध्ये कार्बन डायऑक्साईड तयार होतो आणि आपण तो कार्बन डायऑक्साईड एन्व्हायरमेंटमध्ये एक्झेल करतो. सो दॅट इज द प्रोसेस ऑफ रेस्पिरेशन. But thank God that new cells are generated in our body. That is why we are alive. If that process stops, generation of new cells, so it is as equivalent as we are dying. Okay, so no new cells are generated and only respiration process is taking place. So and if the temperature is higher, in that case this deterioration process or respiration process is higher. ओके, आपलं आपण त्याला दुसऱ्या केसमध्ये मेटाबॉलिझम म्हणतो. आपला मेटाबॉलिझम जास्त आहे. तसं मी रनिंग करत असेल तर माझा मेटाबॉलिक रेट वाढतो. त्या केसमध्ये काय होतं फूड लवकर आपलं डायजेस्ट होतं आणि लवकर लवकर ती एनर्जी जास्तीत जास्त एनर्जी त्यातून जनरेट होते. सो दॅट इज द मेटाबॉलिक रिएक्शन्स. Okay, so this reactions we have to slow down. In that case, we require lower temperatures. Third is to remove the heat. We need to know what are the cooling loads will be. So first, so yes, of course, we are going to install one refrigeration system. But before that, we should be aware that how much heat we have to remove. असं नाही की मी घेऊन आलो एक 10 टनचा एसी रेफ्रिजरेशन सिस्टम घेऊन आलोय लावले. माय रिक्वायरमेंट फक्त 6 टनचीच आहे. सो आय एम वेस्टिंग दॅट 4 tons of energy. 4 tons means 4 into 3.5, whatever the kilowatt will come, that time wasting unnecessarily. So in that case, it is best practice, and first step it is to calculate the cooling load. So similar process will follow in air conditioning also. So when I go for a mall or if I go for office building, in that case I have to install this air conditioning system. In that case also I have to calculate what are the heat loads that are acting on that building. Okay, कोणते लोड ऍक्ट होते ते मला माहित झाले, किती लोड ऍक्ट होते मला माहित झालं, त्यानंतर किती लोड काढायचं हे मला ऑब्व्हियसली कळते. मग त्या लोड काढण्यासाठी जी मला सिस्टीम लागणार आहे रेफ्रिजरेशन सिस्टीम, दॅट आय कॅन इझिली डिझाइन. Okay, so first step is to calculate the cooling load. So we see one by one what are the loads acting on a cold room. So first one is the transmission load. So you have studied in HMT. Heat is transferred in 3 modes. First is conduction, second convection, and third you have studied radiation. So you have not studied actually radiation, and I think convection part also major part you have missed. But in heat transfer occurs in these 3 modes. So you can see in the diagram there is a cold room. Okay, so it has a roof here, then it has walls. So it has 4 walls, 1 roof and 1 floor. So in this case heat is being transferred from roof. Okay, so how it will transfer? So see here, so these are called as puff panels which are used for cold storage and cold room. हे असे puff panel असतात. बाहेरचं मटेरियल ते स्टील असते. Okay, and inside there is a rock wool. So this is the main our insulating material. So this kind of panels are being used. So if this is outdoor and this is a cold room side, what will happen in this case? Solar energy will come, so it will be transferred through these panels. So conduction first will take place through this wall. So conduction, heat will be transferred, and from this surface there will be convection. Okay. So first conduction and then convection will occur, and heat will be transferred inside the cold room. So it will be transferred from roof, from the above, from side, that is walls, and it also can transfer through floor. आता हे डिपेंड करते की तुमचं कोल्ड रूम कसं कुठं आहे. हे जर जमिनीवर असेल तर इन दॅट केस यू हॅव टू कॅल्क्युलेट द हीट ट्रान्सफर थ्रू ग्राउंड. आणि हे जर तुमचं कोल्ड रूम दुसऱ्या कोल्ड रूमवर असेल, जसं की मल्टी स्टोरेज असेल किंवा एका कोल्ड रूमवर दुसरी कोल्ड रूम असेल, त्या केसमध्ये ते हीट ट्रान्सफर झिरो असणार, कारण आपण काय केलं की खालची देखील कोल्ड रूम एअर कंडिशन केली किंवा त्याला रेफ्रिजरेशन सिस्टीम प्रोव्हाइड केली. इन दॅट केस देअर हीट cooling load will be zero. But if that whatever room beneath this cold room is, if it is not refrigerated or air conditioner, in that case we have to take into account that cooling load also. Okay. So transmission load, so in that case first you have to calculate through walls. Okay, through walls, so it will be Q1. So what will the formula here in this case? It will be overall heat transfer coefficient U. So you might have studied this also. So if I have composite walls, or if I have, in this case I have first conduction and convection, in that case what we are using, we are calculating the RTH. Okay, I am calculating the RTH, so I will calculate the R by conduction plus R by convection, and the U will be that 1 by RTH. Okay, so this is how we calculate this overall heat transfer coefficient. So this is a U into area, okay, into delta T. So delta T will be T outdoor minus T indoor. Okay, so this will give you the value in kilowatt per kg. Okay, so if you want to calculate this kilowatt hour per day, in that case you have to multiply by 24. So this will be 24 hours divided by 1000. So this will be in kilowatt. So this will give you this value in kilowatt hour per day. Okay. Similarly, this is a through walls. Second will be through floor. So in that case, this Q2 will be equal to UA. So I am assuming that U value is constant for all walls, into A, area of floor, into T of floor minus T in, again into 24 divided by 1000. So this will be again kilowatt hour per day. Okay, so that unit is used while calculating this cooling load, that is a kilowatt hour per day. So write down these two formulas. So we will be using this in our upcoming calculations. So transmission loads, that is heat transferred through walls. First it will be transferred through conduction and then convection. In that case, first we can calculate through walls. Okay, so this will be through walls. This will be the formula UA into T outdoor minus T indoor into, so whatever you see here into 24 by 1000, that is just unit conversion. We are getting the values in terms of kilowatt hour per day. Then second is through floor, and there are two cases. This cold room may be situated on ground, or it may be situated on another cold room. Okay, so that you have to see here. So through floor, that Q2 will be equal to again Q into A into delta T. Delta T will be here in the case temperature of floor minus temperature indoor. Again into 24 by 1000, that will give you value in terms of kilowatt hour per day. Okay, so write down these two formulas. Because we are going to I will give some dimensions, and then in that case we have to design this system for this cold room. So for that you have to write these formulas. So see here what it is saying, heat always flows from hot to cold. So this is a we all know that non-reversible reactions or non-reversible processes. In that case, heat always flows from hot to cold. The interior of a cold room is lower temperature than its surrounding, so heat is always trying to enter. Okay, so that is the natural or irreversible processes that heat always flows from hot temperature to low temperature. And in case of pressure, we know that fluid always flows from high pressure to low pressure. So in this case, that heat is always trying to enter in this room. So we have to remove that heat with the help of refrigeration system. It says that higher if exposed to direct sunlight. आता हीच cold room मी जर building मधून बाहेर काढून direct sunlight मध्ये ठेवले, in that case what will happen? More heat will be transferred inside the cold room. So for that I have to keep it inside my building. Okay, so I hope you have written this formulas. I'll move to the next. Now next is product loads. Product loads means whatever product I am keeping inside that cold room. So in that case, what you see on the screen, there is one apple is there. Okay, so I am keeping an apple inside a cold room. Now there will be two loads. So if the apple is at room temperature, suppose 35 degrees Celsius, and I am keeping it inside a cold room which is at 4 degrees Celsius, obviously there will be some sensible load. Sensible load means because of this temperature difference, so sensible load will act on the cold room. ठीक आहे, म्हणजे मी एक समजा 10 किलो ऍपल घेतले आणि कोल्ड रूम मध्ये ठेवले, इन दॅट केस काय होणार आहे, ते सेन्सिबल लोड त्या कोल्ड रूम वर ऍक्ट होणार आहे, कारण ऍपलचं टेम्परेचर हे कोल्ड रूम पेक्षा जास्त आहे. Second will be respiration heat. The respiration process I have explained you that in that case what we take inside oxygen, and oxidation takes place of organic substances, that carbon dioxide generated, and we are exhaling that carbon dioxide. So see, this oxidation process, whichever you take in the world, it is a exothermic reaction. In that case, some energy is being rejected. Okay, so that also we have to take into consideration. So see here what it says. So this account for heat that's introduced into the cold room when the new products enter. It is also the energy required to cool, freeze, and further cool after freezing. Okay. So first thing here, it is in the sensible cooling. So this you have to take into consideration. Second is latent heat. So if I want to freeze any product, जसं की आईस मला तयार करायचं, आईस मध्ये सेन्सिबल हीट रिमूव्ह करावं लागते, प्लस त्याचं आईस मध्ये कन्वर्ट करावं लागतं. इन दॅट केस आय हॅव टू रिमूव्ह लॅटेंट हीट ऑल्सो. दॅट ऑल्सो हॅव टेकन इन टू अकाउंट. ऍपल मध्ये गरज नाही, ऍपल किंवा फूड्स असतात त्या केसमध्ये लॅटेंट हीटची आपल्याला गरज नसते. Then third is product respiration heat. So that respiration is an oxidation process. Oxidation process, we know that is exothermic reactions. That means energy is being rejected. So that will be also act as a load, a thermal load on the cold room. हे जे आपण सगळे लोड कॅल्क्युलेट करतोय तर ते आपल्याला त्या सिस्टीम मध्ये रिमूव्ह करायला लागणार आहे. तर रिमूव्ह कसं करणार, त्यासाठी मी काय करणार, एक रेफ्रिजरेशन सिस्टीम त्याला जोडणार. सो इन दॅट केस दॅट हीट विल बी रिमूव्ड. Okay, so in this case see here, so I have Q3. So this Q3 is nothing but heat exchange, or we can say that sensible heat. So first I have to remove the sensible heat. So Q3 will be equal to mass of this apples into MCP, or whatever food we are using. MCP, CP means of that food, specific heat of food, into temperature of that apple. Okay, temperature of food minus indoor temperature. Okay, so if I want to convert this into kilowatt hour, so I have to divide it by 3600. So this will give you in again kilowatt hour per day. So this mass, whatever m you are I'm writing here, this is a mass of apples or the food per day. So this will ultimately give me the unit in per day. So this will be kilowatt hour per day. Okay, and the second will be respiration. So respiration, that will be equal to Q4 is equal to mass, whatever that is there, and then respiration rate of that fruit or vegetable, respiration rate. So if you Google this respiration rate, you will get some values in the form of tables. The apple चे किती आहे, banana चे किती आहे, पालक भाजी तुम्ही घेतली त्याचा रेस्पिरेशन रेट किती आहे ते तुम्हाला व्हॅल्यू मिळून जातील. And if I divide this by again 3600, so see here again this mass is kg per day. Okay, so here it is kg per day or tons per day. So this will again give you the value in kilowatt hour per day. Okay, so write down these two formulas also. Okay, see what it says here, product load. Okay, product load, it is 55 to 70% of total. So if I calculate total load, the percentage share of this product load, it is around 55 to 75. So in that case, product exchange, then cooling, freezing of products and packaging, product respiration heat. So all these we have to consider. So up to now we have considered first transmission, which is a 5 to 15% in total load, then product load, which is about 55 to 75%. It says if cooling, then calculate sensible rate. Only we have to cool. So no freezing is required. In that case, we have to take into consideration only sensible heating. If freezing, then calculate sensible plus latent heat as phase change occurs. Okay. So this article you can find on this website, which is the engineering mindset. From there, I have taken this cooling load calculation for a cold room. Okay, so I hope you have written these formulas for sensible heat and respiration rate. Third is internal loads. So what I am doing actually now, I am calculating the what are the loads acting on a cold room. So in that case, first we are seeing transmission load, that is through conduction convection. Second, we are seeing product load, that is the load or the heat rejected by the product, what we are keeping inside the cold room. Third is internal loads. Now internal loads, as the name suggests, it is the load caused by the internal elements. आता इंटरनल एलिमेंट्स कुठले कुठले असतात कोल्ड रूम मध्ये, जसे की एक लाईट असेल, ठीक आहे, त्यामध्ये एक फॅन असेल, त्यामध्ये एक पर्सन आत बाहेर करतोय. सो ऑल दॅट वी हॅव टू कन्सिडर अंडर द इंटरनल लोड्स. ओके, तर तुम्ही बघितलं असेल तर फ्रीज आपण उघडलं की ती लाईट लागते, फ्रीज बंद केल्यानंतर आत लाईट बंद होत असते, जरी आपल्याला कळत नसतं तरी आतल्या ती लाईट बंद होत असते. सो दे आर युजिंग दिस मॅग्नेटिक रीड स्विचेस. Okay, so this because when this two magnets comes in contact with each other, that circuit is completed, and in that case, that bulb or whatever light we are providing inside the fridge, it switches off. तर असं ते सिस्टीम असते. फक्त उघडल्यानंतर तुम्हाला लाईट दिसते, आत बंद केल्यानंतर ते लाईट बंद होते. का असं तर लाईट देखील त्याच्यातून काहीतरी एनर्जी और हीट रिलीज करत असते. तर त्या हीटमुळे काय होते, त्या सिस्टीमवरचा लोड वाढत असतं. हे झालं लाईट बद्दल. सेकंड आहे पर्सन. नाव इफ द पर्सन एंटर्स अ कोल्ड रूम अँड ही लिव्स, so when a person comes inside, so he is coming from a temperature of outdoor environment. Okay, suppose at 35 degrees Celsius, and he is entering an environment which is at 4 degrees Celsius. So definitely he will carry some sensible heat along with him. Also, plus there will be some metabolism rate. Suppose the person has taken lunch, or he is coming after running a mile. In that case, that metabolism rate will be higher. So that also that will also increase the rate of release of heat. So all those factors we have to consider under the heat loads, internal heat loads. So I read this. So this is the heat given off by people working in the cold room, the lighting equipment such as forklift, trucks, etc. Okay. ट्रक तर नसतात, पण फोर्कलिफ्ट ज्या तुम्ही बघितलं असतील ते सामान म्हणजे फॅक्टरीमध्ये किंवा वेअर हाऊसिंग मध्ये जर तुम्हाला ट्रान्सफर करायचं असेल त्या केसमध्ये फोर्कलिफ्ट वापरली जाते. Okay, so how to calculate this? See here. So first I will calculate the load which is exerted by people. So let us say that is a 5 Q5. So that will be number of people. Then that into heat rejected per person. So this heat rejected is directly linked to its metabolism rate. Then cooling time. Okay. Cooling time means how many time that person spends in that cold room. So that you have to take into consideration. And this whole divided by 1000. So this will give in kilowatt hour per day. Okay. So this cooling time what we are calculating that is a per day. एका दिवसामध्ये एक माणूस किंवा जेवढी माणसं आहेत ते कोल्ड रूम मध्ये किती वेळ घालवतात. So that will be considered under cooling time. So generally this heat rejected, this value we are taking it as a 270 watts. So this is the amount of heat rejected by a person who is entering from outdoor conditions. So definitely this value will be different for different temperature values, but in general we are taking it as a per person we are emitting 270 watts of energy. And second we have a lighting load. So suppose there are some lights are provided, so lighting load. So that will be Q6 is equal to number of lamps, then into time for which that the lamp is on, then into wattage. So whatever wattage is there for that tube that we have to provide here. Again, if I divide by 1000, this will give me in kilowatt hour per day. Okay. So write down this formulas. Okay, so I hope you have written this. We'll move to the next load. Next is refrigeration equipment load. So obviously, if you are using a refrigeration system, that whatever equipment, what are the instrument inside that refrigeration system, that will also emit some heat. So in case of refrigeration system, we have fans, which causes movement of air. So fans, this fan have their motors. So we know that motors emit some heat after continuous uses. So that also we have to take into account. Plus, we know this process of frosting. So in this case of evaporator, so when the temperature of evaporator falls very below the dew point of air, so in that case जेव्हा ड्यू पॉइंटच्या खाली त्याचं टेम्परेचर जातं त्या केसमध्ये काय होतं कंडेन्सेशन स्टार्ट्स ऑन द कॉइल ऑफ इव्हॅपोरेटर त्यावेळेस वॉटरचं कंडेन्सेशन होतं आणि त्या वॉटर लिक्विड वॉटरचं परत आईसमध्ये कन्व्हर्शन होतं म्हणजे काय होतं का एका ठराविक फेज नंतर तुम्हाला तुमच्या इव्हॅपोरेटर कॉइलवर बर्फ जमा झालेला दिसतो सो दॅट इज द प्रोसेस ऑफ फ्रॉस्टिंग टू रिमूव्ह दॅट आईस वी हॅव टू यूज डिफ्रॉस्टिंग आता डिफ्रॉस्टिंगच्या दोन मेथड आहेत एक तर तुम्ही तुमची रेफ्रिजरेटर सिस्टीम हे रिव्हर्स करा त्या केसमध्ये तुमचा इव्हॅपोरेटर हा कंडेन्सर होईल आणि कंडेन्सर इव्हॅपोरेटर होईल किंवा तुम्ही एक हिटिंग कॉइल वापरा हिटिंग कॉइल वापरून तो बर्फ वितळून टाका So in this case, we are using heating coils. So heating coil will have some capacity in wattage, and also they will have some efficiency of heat transfer. So that also we have to take into account. Okay. So for this, we want to know the rating of the fan motors and estimate how long they are run for each day. Then we want also to account for any heat transfer into space from defrosting the evaporator. Okay, so we have to consider fan and defrosting of evaporator. So it says that it is at 1 to 10% of total load, evaporator fans and evaporator defrost cycle. आता डिफ्रॉस्ट सायकल म्हणजे काय असतं तर ज्यावेळेस तुम्ही इव्हॅपोरेटर डिफ्रॉस्ट करता त्यावेळेस आईस काढून टाकता तर तुम्ही ते दिवसात किती वेळा केलंय तर जनरली ते एक दिवसातून 4 वेळा करावं लागतं म्हणजे 4 वेळा त्या ऑपरेटरला जाऊन डिफ्रॉस्टिंग करून तो आईस काढावा लागतो सो दॅट नंबर ऑफ सायकल्स ऑल्सो वी हॅव टू कन्सिडर इन डिफ्रॉस्टिंग इव्हॅपोरेटर देन नेक्स्ट इज सेल फॅन मोटर्स give off heat when in use evaporator need to defrost so this is the process what is shown here in the defrosting त्याचा वरचा जो आईस आहे तो आईस मेल्ट होतोय and this is a fan so fan motor will also emit some energy or heat okay so in this case first we'll see evaporator fan okay evaporator fan त्या केस मध्ये Q7 ठीक आहे so we have written up to Q6 so Q7 will be equal to number of fans okay into time so number of time it was running okay so this can be in hours into wattage what is the wattage and divided by 1000 so this will give the value in kilowatt hour per day okay so this time is number of hours that fan is on per day एका दिवसात ते फॅन किती तास चालू होता ते आपण इथं काउंट करतो then we are counting the number of fans then we are counting the wattage and divided by 1000 that will give in kilowatt hour per day the second thing here it is defrosting okay so how to calculate defrosting so Q8 will be equal to power of heating element so I'm assuming that I'm using a heater whatever power of that heating element into time okay into cycle so time means number of the time duration for which it is defrosting is occurred म्हणजे एकदा डिफ्रॉस्टिंग करायला किती वेळ लागतो आणि इंटू सायकल मीन्स एका दिवसात मी किती वेळा ते डिफ्रॉस्टिंग करतो सो दॅट विल बी इंटू नंबर ऑफ सायकल्स इंटू इफिशियन्सी इंटू इफिशियन्सी म्हणजे हिटर कॉइलची इफिशियन्सी किती आहे ते किती वॅटेज घेते आणि त्या वॅटेज मध्ये किती एनर्जी त्यानं इव्हॅपोरेटरला ट्रान्सफर केली फॉर द पर्पज ऑफ डिफ्रॉस्टिंग सो दॅट विल बी कन्सिडर अंडर इट्स इफिशियन्सी okay this answer should be in again kilowatt hour per day Okay, so I hope you have written this formula. We'll move to the last step, last load, which is a infiltration load. इन्फिल्ट्रेशनचा अर्थ असा असतो की चोरी चुपे जे तुमच्यात हिट ऍड केली जाते किंवा जी तुमची हवेची झुळूक ज्यावेळेस तुम्ही खिडकी पूर्ण बंद करता त्यापैकी कुठेतरी गॅप राहिला असतो, त्या गॅप मधून एअर हवेची एक झुळूक येत असते किंवा आपला दरवाजा असतो, दरवाजाच्या खाली एक फट आपण थोडे ठेवतो, त्या फटीतून देखील एअर आत येत असते. तर हे सगळे जे आहे जिथून आपण जरी आपण सगळे रूम सील केली तरी कुठून तरी हवा येतेच, त्याला आपण काय म्हणतो, इन्फिल्ट्रेशन. ओके. So this occurs when the door opens, so there is a transfer of heat into the space through the air. So whenever this air from the outside comes inside, obviously that outside air is at outdoor conditions, 35 degrees Celsius, 40 degrees Celsius. It comes inside at temperature of 4 degrees Celsius. So there will be some sensible load that air will carry inside the cold room. So that also we have to take into consideration. The other consideration is ventilation. Fruits and vegetables give off carbon dioxide, so some stores will require ventilation fan. This air needs to be cooled down, so you must account for this if it is used. ज्यावेळेस तुम्हाला फ्रेश एअरची रिक्वायरमेंट असते तर त्या फ्रेश एअरचा देखील लोड तुम्हाला कॅल्क्युलेट करावा लागतो. आता आपण ज्या सेकंड सेक्शन मध्ये एअर कंडिशन सिस्टीम पडू त्यावेळेस तुम्हाला कळेल की ज्यावेळेस एक समजा एच असतं, ठीक आहे, एअर हँडलिंग युनिट असतं, ते काय करत असतं, सप्लायर देखील सॉरी एच काय करत असतं, तुमचं फ्रेश एअर देखील घेत असतं प्लस रिटर्न एअर देखील घेत असतं, हे दोघीचं मिक्सिंग करून ते काय देत असतं मला, सप्लाय एअर देत असतं. तर त्या केसमध्ये फ्रेश एअरचा लोड तुम्हाला कन्सिडर करावा लागतो, का तर फ्रेश एअर ही आउटडोर कंडिशन मधून आलेली असते. सो दॅट इज द लोड कॅरीड बाय द फ्रेश एअर. ओके. So infiltration load, it is 1 to 10% of total air infiltration and ventilation. These two factors we have to consider. Some cold storage require mechanical ventilation. Fruits and vegetables produce carbon dioxide. So that carbon dioxide we have to take it out. So we have seen these loads now, cooling loads. First we have seen transmission, which is a 5 to 15%. Then we have seen product load, which is a 55 to 75%. Then internal loads, that is the load of people and load of lighting, that is up to 10 to 20%. Then we have seen load of equipment, which is a 1 to 10%. Equipment means fans and defrosting. Then last we have seen infiltration. Infiltration load is also 1 to 10%. So all these loads we have to take into consideration. Then you have to sum all these loads. So you will get a total load. Based on that total load, you have to design a refrigeration system. जॉब तुम्ही लक्षात घ्या, पहिल्यांदा तुम्हाला काय करावं लागतंय, कुलिंग लोड काढावा लागतोय. त्यानंतर तुमचा जॉब येतो की कोणती सिस्टीम तुम्ही सिलेक्ट करायची, रेफ्रिजरेशन सिस्टीम. मग तुम्ही मल्टीस्टेज इव्हॅपोरेटर सिस्टमला जाऊ शकता, मल्टीस्टेज कॉम्प्रेशनला जाऊ शकता. म्हणजे त्या काही सिस्टीम आपल्याकडे चॉईसेस आहेत समोर, त्या सिस्टीम आपण चूज करू शकतो. पण त्याच्या आधी आपल्याला काय माहित पाहिजे, किती लोड सिस्टीमवर ऍक्ट होतोय. ओके. So in this case, if I want to calculate the infiltration load, so let us it be QIF is equal to, so this will be equal to number of volume changes. Number of volume changes. आता नंबर ऑफ व्हॉल्यूम चेंजेस म्हणजे काय असतं, त्याला दुसऱ्या भाषेत असं देखील म्हणतात एसीएच. एसीएच म्हणजे एअर चेंजेस पर आवर. म्हणजे काय होतं की एअर फिल्ट्रेशन मध्ये तुमची बाहेरची एअर आत येते, ज्यावेळेस मी दरवाजा उघडतो त्यावेळेस काय होणार आहे, ऑटोमॅटिकली बाहेरची एअर आतमध्ये एंटर होणार आहे. त्या केसमध्ये काय होतं की आतली एअर रिप्लेस होणार आहे. म्हणजे तुम्ही एका दुसऱ्या पर्स्पेक्टिव्ह जर बघितलं तर काय वाटतं, त्यात बाहेरची एअर आत येते आणि आतली एअर रिप्लेस होते. तर तुमच्या रूमचा जो टोटल व्हॉल्यूम आहे तो व्हॉल्यूम दिवसात किती वेळा रिप्लेस झाला, सो दॅट विल बी एअर चेंजेस पर आवर. तुमच्या रूमच्या व्हॉल्यूमची जेवढी एअर आहे, एअर व्हॉल्यूम जेवढा तुमच्या रूम मध्ये बसतोय तो किती वेळा तुमच्या फ्रेश एअरने रिप्लेस झाला, सो दॅट विल बी एअर चेंजेस पर आवर. दॅट इज अ नंबर ऑफ व्हॉल्यूम changes. Okay, this number of volume changes into energy. Okay, energy means that energy carried with the air. So generally we are taking that specific heat into density of air. This is related to the Cp value into outdoor temperature minus indoor temperature into So divided by 3600, divided by 3600. So this will give you the unit in kilowatt hour per day. Okay. What I am doing here, I am first considering some ACH. ACH means number air changes per hour. म्हणजे एका दिवसात त्या रूम मधला व्हॉल्यूम किती वेळा फ्रेश एअरने रिप्लेस झाला, तर ते असतं एअर चेंजेस पर आवर. त्यानंतर एनर्जी म्हणजे त्या एअरची स्पेसिफिक हीट आणि ते इंटू त्याची डेन्सिटी, हे तुम्हाला जी व्हॅल्यू मिळते असते एनर्जी into delta T, that is a T out minus T in divided by 3600. So that will give you the value in terms of kilowatt hour per day. Okay. So write down this formula, and soon we'll start one problem. So we'll take a code room and we'll put apples in it, and then we have to decide like what will be the total load acting on that cold room. Okay, so I hope you have written this formula. Now we'll take one problem. So we'll take one apple cold room. So my objective is to store the apple at a lower temperatures. So I'll give you some size for this. So size means internal dimensions of that cold room. So let us say that is a 6 meter into 5 meter wide into 4 meter is height. What a cube. Then food, whatever food I'm using, in this case it is a apple. The apple लक्षात घ्या. I'll give some values. CP in that case. So CP means specific heat of apple. It is given as 3.65 kilojoule per kg Kelvin. Okay. And the next thing, for this apple, we know that they have given this respiration rate. So respiration rate for apple, it is 1.9 kilojoule per kg per day. Okay. म्हणजे एका दिवसात पर केजी ऍपलच्या 1.9 किलोजूल एनर्जी बाहेर पडते थ्रू द प्रोसेस ऑफ रेस्पिरेशन. Okay, respiration we know that is the oxidation reaction. That is why it is an exothermic reaction. That means energy is being released during the reaction. Okay, so food is apple. Their constant values are given. Then quantity. आता किती quantity आपण ठेवतो त्यात. सो 4000 kg पर डे, म्हणजे दररोज मी त्यामध्ये काय ठेवतोय 4 टन माल म्हणजे ह्याचा ऍपलचा त्यामध्ये ठेवतोय. आता ह्यामध्ये बघा थोडे समजून घ्यायची गोष्ट आहे की एक कोल्ड रूम जरी किती जरी मोठी असली, ठीक आहे, ही जर तुमची कोल्ड रूम आहे, ओके, ती मी काय 100% भरू शकणार आहे काय? टोटल त्याचा व्हॉल्यूम मध्ये सगळीकडे ऍपल ऍपल भरले असं होणार आहे काय? असं होऊ शकत नाही, कारण मला ते लोड करायला असतं, मला अनलोड करायला असतं, त्यामध्ये ऑपरेटरला फिरता आलं पाहिजे, लाइटिंग लावता आली पाहिजे, बरेचसे जे फॅन आहे तुमचे फॅन देखील इन्स्टॉल करता आले पाहिजे. त्यामुळे असं अजून करतात की कोड रूमच्या साईजच्या फक्त 50% तुम्ही वापरू शकता. ठीक आहे, फक्त 50% स्पेस तुम्ही वापरू शकता. त्यात पण 20% जे आहे, 20% जे आहे ते तुम्ही लोडिंग आणि अनलोडिंग मध्ये कन्सिडर करता. म्हणजे थोड्या वेळानं 20% माल त्यातून वजा होतोय, परत थोड्या वेळानं ऍड होतोय, हे सगळं त्यामध्ये कन्सिडर केलं जातं. आता आपण जे बघतोय ते 4000 kg पर डे आपण त्यात टाकतोय, पण त्यातून काही माल काढला देखील जाणार आहे, परत टाकला देखील जाणार आहे. सो दॅट वी हॅव टू कन्सिडर. देन वी हॅव टू कॅल्क्युलेट एका दिवसात त्याच्यात किती मॅक्सिमम किती वजन आपण त्यात ठेवू शकतो, ते आपल्याला त्यातून कॅल्क्युलेट करावं लागेल. ठीक आहे, आता आपण ह्या केसमध्ये फॉर इन्सुलेशन वी हॅव युज्ड अ पफ पॅनल. ठीक आहे, फॉर इन्सुलेशन I'll give some numbers here: 2, 3, 4. For insulation we have used puff panels, PUF panels. आता त्याचा U व्हॅल्यू फिक्स आहे, या केसमध्ये आपल्याला दिला आहे. पफ पॅनलचा U व्हॅल्यू इट इज गिवन एज 0.28 वॅट पर मीटर स्क्वेअर केल्विन. दिस इज अ ओव्हरऑल हीट ट्रान्सफर कोएफिशियंट. जनरली त्याची थिकनेस असते 80 mm. ओके, then fifth, in this case, temperature. So we'll see what are the temperature values we are considering here. So outdoor temperature मी काय करणार आहे केस मध्ये? So I have taken this outdoor temperature as 30 degree Celsius and 50% RH. Then next thing is indoor temperature. आता म्हणजे ते कोल्ड रूम मध्ये मी किती टेम्परेचर आत ठेवतोय, तर ते असेल इंडोर टेम्परेचर. इन दिस केस इट इज 1 degree Celsius and 95% RH. That is a relative humidity. What is RH? We'll see in later in second section. Relative humidity. It is actually the ratio of moisture content in the air to that in the air. So we are taking the ratio of moisture content and total weight of the dry air. Then temperature of floor. I am keeping that cold room on the ground. So in that case, temperature of floor, it is given as 10 degrees Celsius. Okay. Temperature of fruit. So though the fruit we are taking from the outside, in this case that fruit is pre-cooled, it is pre-cooled to 5 degrees Celsius. Then it is stored inside the cold room. Okay, so this is related to temperature. Sixth is given for the lighting. त्यामध्ये कुठले किती किती लाईट वापरलेत बघा. सो वी हॅव युज्ड 3 लॅम्प्स. प्रत्येकाचं वॅटेज आहे 100 वॅट वॅटेज आहे, and they are on for 4 hours per day. एका दिवसात ते 4 तास चालू असतात. ठीक आहे, this is related to internal loads. Again speaking of internal loads, we have people. So in this case we have 2 people. Okay, they are also working on an average 4 hours per day. Okay, in seventh we have this equipment load. In that case we have fan. ठीक आहे, तर फॅन मध्ये काय आहे आपल्याकडे? एक फॅन आहे with a wattage of 200 wattage and it is running for 14 hours per day. That means their system is running for 14 hours per day. आता हे फार इंटरेस्टिंग आहे. तुम्ही म्हणताल की एखादं कोल्ड स्टोरेज किंवा कोल्ड रूम 24 तास चाललं पाहिजे, त्याला सारखी हीट रिमूव्ह करावं लागते, तर तसं काही नसते. फक्त डे आवर्स मध्ये ज्यावेळेस बाहेरचा लोड थर्मल लोड जास्त असतो, त्या केसमध्ये फक्त आपण सिस्टीम रन करायला असते. मोस्टली नाईट टाइमला कोणी देखील सिस्टीम चालू ठेवत नाही. इव्हन आपल्या पंढरपूरच्या शेजारी जे कोल्ड स्टोरेज आहे त्यातल्या बळीराजा, तर ते मोस्टली या सीझन मध्ये तर फार त्यांचं 8 ते 10 तास सिस्टीम चालू असते. ज्यावेळेस समर असतो त्या केसमध्ये मात्र त्यांना किती आकडा सांगितलेला त्यांनी, ऑलमोस्ट 18 आवर्स त्यांना सिस्टीम रन करावं लागते. म्हणजे दिवसात फक्त 4 तास सिस्टीम बंद आहे, बाकी 18 तास सिस्टीम चालू आहे. सो इट डिपेंड्स ऑन आउटडोर कंडिशन्स ऑल्सो. Okay, so there is one fan for 200 watt which is working for 14 hours per day. Now next is defrosting. So under that seventh only we can write the defrosting. So defrosting of evaporator. Okay. So in this case they have used one heating element of 1.3 kilowatt. Okay, which is running for 30 minutes and it is used 3 times पर डे. ठीक आहे, 30 मिनिट एका वेळेस 30 मिनिटं चालणार असे मी 3 times पर डे सिस्टीम वापरली. ओके, 3 times per day and its efficiency is 30% efficiency. That means whatever wattage it is taking from the board, electricity board, out of that 30% it is utilized as heat. This is about the equipment load. The next is infiltration. So in this case, it is assumed that there will be 5 volume changes per day. Okay, 5 volume changes per day. So this is the given data for in front of us. First, we'll solve this problem by manual calculations. Then we'll use the software. So this Danfoss company, they provide this software for the calculation of heat load. That also we'll see in the end. But before that, we'll calculate manually what are the cooling loads acting on this cold room. Okay, so we'll start with first transmission load. Okay, so I have discussed with Kobne sir. So today I will extend this lecture. We'll do this calculation. Okay. So first thing in calculation is transmission load. That is a heat transport by conduction and convection. Okay. So transmission load. Okay. Transmission load. So we know we have written this formula for transmission load. So Q1 is heat transfer through walls. So that will be equal to Q U into A into delta T. That is a T out minus T in into 24 divided by 1000. So before that we have to calculate the area. ठीक आहे, आता आपल्याकडे ह्या केस मध्ये बघा एक कोल्ड रूम आहे. Okay, okay. So Sonal sir is going to take the lecture. Okay. Because those lectures are for both the divisions, I cannot extend my lecture. Anyway, we'll continue this calculation tomorrow also. So tomorrow we'll take a lecture in the same timing, though there is a project day. But meantime, this Rubicon training is there. We'll not take project days, so we'll take a lecture. So we'll continue this calculation tomorrow. Okay. So we'll start with transmission load. We'll calculate all the loads. Then we'll calculate total load. Then we'll design the refrigeration system. Manually first we'll do. Then we'll do on software. Okay. So quickly I will take the attendance.